3-3, parallel and perpendicular lines. Alright, so Theorem 3-7, if two lines are parallel to the same line, then they are parallel to each other. So if you look here, it says if A is parallel to B and B is parallel to C. And they've got the markings to show that A and B are parallel and that B and C are parallel, but they don't indicate that A and C are parallel to each other. But this is basically the transitive property. Since B is parallel to both A and C, so you have one line that is parallel to two other ones, then we automatically know, even though C is not marked parallel to A, that A is in fact parallel to B. All right, so this would be your transitive property. If A is parallel to B and B is parallel to C, then you automatically know that A is parallel to C. All right, so just because C is not marked parallel to A, we automatically know it is parallel to A because both A and C are parallel to B. All right, make sure you're writing this stuff down in your notes so you remember it all. Theorem 3-8. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So in this case, even though there's no markings that indicate that M is parallel to N, since M is perpendicular to T, and N is also perpendicular to T, all right, since they're both perpendicular to the same line, all right, you can use, in this case, you can use the converse of the corresponding angles theorem to say, since corresponding angles are congruent, that means your lines are parallel. All right, this is kind of an extension of that. So corresponding angles are congruent. Both of these are right angles. So both M and N are perpendicular to the transversal T. Since they're both perpendicular to T, that means they are parallel to each other. All right, they are parallel to each other. Now this last one is your perpendicular transversal theorem. Basically, it goes along some of the same lines as this one. It says, in a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So here it says, if N is perpendicular to line L, and L and M are parallel, then N and M are also perpendicular. Well, you can also look at this as you have two parallel lines cut by a transversal. All right. So, and we know that this is a 90-degree angle. So since this angle here and this angle here are corresponding angles, all right, since we know it's a corresponding angle, we also know that this has to be a 90-degree angle just like this one is. All right, so in that case, we know that N is also perpendicular to M. All right, so since N is perpendicular to L and N and L and M are parallel, then N is perpendicular to M. All right. Now, we can also take this a slight step further to where if we had two lines cut by a transversal, like so, and to make sure they're parallel, I'm going to clone this one so it'll keep it at the same slope. All right. Now, we know that this angle here will have to be congruent to this angle here if these two lines are parallel, right? Because these are both corresponding angles, right? Since they're both corresponding angles, since these lines are parallel, we know these two angles have to be congruent. Or if we knew that these two angles were congruent, we would automatically know that these are parallel. Even though they're not 90 degrees or anything like that, since we know that that these two angles are congruent, we know that these are parallel. Or since we know that these are parallel, we know these two are congruent. All right, so it doesn't only work with 90 degrees, it also works with other degrees. Like say this could be, I don't know, we could say these are 60-degree angles. All right, since these are 60-degree angles, we know the lines are parallel. Since we know these lines are parallel and this is 60, we know this would have to be a 60-degree angle as well. And even if we added a third line up here, even if we added a third line, it would still be the same thing. All right, now this third line, I'm not going to mark it parallel. All right, I'm not going to mark the third line parallel, but what I am going to do is tell you this angle here is a 60-degree angle. So now, since we know that these three angles are all 60 degrees, all three of these lines have to be parallel as well. All right. So I tried to keep this video a little shorter for you. Here's your ticket in the door. Now, this may require some thinking on your part, but these two problems go in line with the three theorems that we just went over. All right, so it shouldn't be too hard for you. It says, number one, a carpenter is building a trellis for vines to grow on. The completed trellis will have two sets of diagonal wood pieces that overlap each other. Letter A, if pieces A, B, and C must be parallel, what's true about angles 1, 2, and 3? All right. Number two, the carpenter attaches piece D so that it is perpendicular to piece A. If your answer to part A is true, is the piece perpendicular to pieces B and C? And then make sure you justify your answer for me. And number two, what conclusions can you make about lines L and M? All right, what conclusions can you make about lines L and M? Feel free to back this up to look at those theorems again if you didn't write them down, but you should have wrote them down, so you should have them in your notes and you shouldn't have to back up. But answer these three questions, because this one has two parts. So answer these three questions and make sure you have it ready when you come to class tomorrow. Good luck.